And so now let's just go ahead and get started, get you some great content, and I'm going to hand it over to Dave.
Thank you, Beth. Good afternoon and welcome to today's webinar on metal clad cables that are used primarily in commercial and healthcare installations. So yes, my name is Dave Watson, Principal Engineer, Southwire, part of the Applications Engineering team. Also heavily involved in the codes and standards part of our business. I'm currently on 2 NEC code making panels for the 2023 code making cycle, and we're already in the midst of working on that. Also on a number of UL standards, technical panels, CSA panels, NEMA, a number of committees there, including the Codes and Standards Committee, which is kind of an overarching committee that regulates the NEMA positions and publications, etc. Also, CANINA technical committees, and then a number of other things there as well. So my focus again then is applications and then the codes and standards side for Southwire. Now, as Beth mentioned, I've done a few of these, and I guess if I have one hallmark in this is that it's hard for me to get through all my slides in time. So just want to warn you, we may not have time at the end for questions. This is the first time I've given this one, so we'll see how it goes. If you think of a question, please enter it into the chat box during the presentation, or you can send your questions to Cable Tech Support, that's all together, one word, Cable Tech Support at southwire.com, and we'll be glad to help you out. Southwire is still headquartered in Carrollton, Georgia. We've made a number of acquisitions over the years. I believe we've made 2 or 3 so far this year, but we're still headquartered in Southwire. Earlier this year, we celebrated our 70th anniversary. So we are I believe, the largest privately owned wiring cable company, perhaps in the world, and I believe we're the 3rd largest overall in the world. So we have nearly 8,000 employees, a number of facilities scattered around the country, and we have been broadening out our product portfolio to include more than just the wiring cable products. We also include tools, assembled solutions, etc. About half of the world's copper rod is going to pass through one of our Southwire SCR, the continuous casting rod systems installed in numerous copper rod mills around the world. We produce half of the wiring cable used for transmission and distribution of electricity for the utility partners. And then half of all American homes contain wiring that is produced by Southwire. So we have a fairly large footprint in the industry. We're delivering solutions, again, for wiring cable, tools. You may have seen our tools out there in the retail space. Component solutions and cable management. These are things that we've added in recent years through our acquisitions of Garvin, Madison, DCN, etc. Our focus is on simplifying the installation of these products to reduce the man hours, labor cost, and make it safer and meet some of those unique application needs. One of our most recent initiatives is called Southwire Speed. This is a service to address needs for expedited product. If you have a minimum, if you have a small order quantity that is typically too small for a minimum order, or you just need some kind of special handling, like a concierge service. So this service is now available. You can reach out to us at swspeed@southwire.com. And so if rather than ending up with a no quote, then hopefully we can help you to turn that into a quote. So please reach out to us if you have any special needs like that. Today, this presentation is focused on armored cables, specifically the metal clad type products. But why do we want these type of products? So the traditional pipe and wire installation has been around for ages, but the armored cable approach has also been around for actually over 100 years. More about that in a minute. But why would we want to do this? Well, you have pre-installed conductors, underneath an armor. And this type of product will allow you to do the installation with substantial labor savings compared to the traditional method. The general configurations that are available in the marketplace are the interlocked armor, which is what we're primarily going to talk about today. Continuous corrugated armor. This is where the armor is welded together at a seam, and it is liquid tight, if you will. So this is the type of construction that would be used in hazardous location versions of the MC cables. Southwire makes that type of product as well. The bottom two, Southwire does not make at this time: braid wire armor and steel wire armor. For the interlocked armor, this is a steel or galvanized steel or aluminum strip that is formed and then helically wound around the conductors, as shown in the video, in order to provide a very flexible yet protected construction for the underlying conductors. We're going to talk a little bit about the history and evolution of these armored cables. So first out of the gate was type AC armored cable, then MC cable, and then further variations have occurred in more recent years with the MCAP cable, where the armor is a grounding path, similar to the way it was in AC cable, but we'll get to that in a moment. There's also the MCAP HCF, or healthcare facility version of the product that has the required redundant ground paths. And then we have MCPCS. PCS stands for Power Control Signal. This is a product for primarily for use with LED lighting applications or any kind of application where you need a control, typically a 0 to 10 volt DC control circuit. But again, more about that once we get a little into this a bit further. So we'll start off with type AC. This was originally listed in 1899, believe it or not, that it goes that far back. Sprague Electric in New York. So initially there were two experimental versions, AX and BX. Well, the BX one was the product that was produced, and then it was named BX cable, and it got to be known by that. So a lot of times you still hear people today refer to this product as BX cable. So, and a lot of times that term is used for type MC products as well as AC. So it can be a little confusing when people are talking about this type of product, these armored cables. But a BX is a name from the past that really was referring to the type AC cable. So this appeared in the NEC in 1903. One of the very earliest UL standards, UL4, is covering this product. And the armor is the ground path. So the original construction, let's see if I can get these up. The original construction of this product did not include a bonding wire underneath the armor, and so the armor was the only ground path. So you can see in the original AC, you had a phase conductor, a neutral, and then the armor as your ground. The bonding wire underneath the armor was added in 1959 to improve the grounding performance. So now in the current version of the type AC cable, you have a 16 gauge bond wire that is underneath the armor, and it helps the armor to be an even better performer than it was previously. And bear with me. There we go. Okay, so the permitted constructions, well, first to back up, UL4 covering type AC cables is what we would call a prescriptive standard. It defines very tightly how the product is made, and that's going to contrast to the standard for the later products that we'll talk about in a few minutes. So the permitted conductor sizes are 14 through 1 gauge, and the bonding wire, the 16 gauge bonding wire, so it's not really a full-size equipment grounding conductor, it's just a bond wire underneath the armor. It does not change as you increase your breaker size and your phase and neutral conductor wire sizes. So NEC 250.122 defines the requirements for the equipment grounding conductor. So in other words, the ability of the cable to handle fault currents. And it defines what those requirements are for a given circuit size. So this product does not have an increase in grounding performance as you go up in conductor size and breaker size. It's limited to 4 current carrying conductors. They're individually wrapped in paper, a little bit like the equipment grounding conductor in a Type NM cable that you may be familiar with. And then those paper wrap conductors are twisted together with the bond wire. And then for the armor, you have interlocked aluminum or galvanized steel tape that you can utilize. There's a graphic for it. So Type AC cable can be installed in many of the places that you would inspect. It needs to be secured every 4.5 feet. Now, it cannot be installed in wet or damp locations. This is a dry location only product, and there is no allowance for a construction method, i.e. a PVC jacket on the outside, for it to be installed in anything other than a dry location. It cannot be installed in places of assembly like theaters, churches, etc. It cannot be installed in hazardous locations or any place exposed to corrosive vapors. So the applications, until the advent of MC cables, this was the alternative to pipe and wire commercial installations. And at a number of these, you can see a number of commercial and institutional, industrial type of applications could use this product. The NEC sections, Articles 300, which is a general section on wiring, and then 320 is the specific one for AC cables. And the applicable standard is, of course, UL4, as we mentioned earlier. Now, what are some frequently asked questions regarding this product? Okay, number one, can it be installed outdoors or underground? The answer is no. This is purely a dry location only product. So even if you put it in another conduit, underground or outdoors, anytime that you install a conduit in those situations, it is assumed that water will get into it, because it will eventually, at least. And so those are considered a wet location, and you cannot install this product there. Can it be embedded in concrete? Again, no, can't do that. Can it be installed in plenum locations? Yes. Now, it is not plenum rated. There is no UL plenum rating for this product. However, there is an allowance by the NEC for particular wiring methods that where they will allow those methods to be installed in a plenum space. Armored products like Type AC cable, Type MC cable, all the different variations of MC, those can be installed in a plenum location. The MC cable, to be installed in a plenum location, has to be without an overall PVC jacket. So the problem in plenum locations is you don't want to have something that burns readily and then puts out a lot of gas that can then be recycled through an HVAC system. So that's why products with PVC on them on the outer part of the product are not a good idea in plenum locations unless they're specially made for that application. There is a plenum rating for small conductor, control, signal, communications type products, but not power products. So those, or maybe limited power type products. So there is a special UL rating that you can get for plenum spaces, but that is not available on the UL standards that work or apply to the power products. So anyways, To get back to this one, yes, due to the way this is designed and made, and the fact that it is listed as one of the acceptable wiring methods in plenum spaces, yes, you can put it there. Are the anti-short bushings optional? No, you have to, on a type AC cable, you have to use those anti-short bushings. How do you install the drain wire? Typically, you fold the drain wire back over, and I'm sorry I don't have a graphic for that. You fold the drain wire back over the armor, and then you apply the fitting over the end of the cable, the end of the armor, and the folded over drain wire. That is the way those fittings are designed. And plus, you're dealing with a 16 gauge wire. It's very small. And so I hear from people about installers about installing this product and making sure that the drain wire is beyond the fitting, and so that way an inspector, when they're looking at the job, they'll see that that drain wire has been properly folded back underneath the fitting. Can it be manufactured with an outer jacket? No, it cannot. And I want to point this out because this is indicative of the limitations with this product. Again, this is a prescriptive type of standard rather than a performance-based standard. And so all of these things that we've wanted to see in armored cable products, this type of standard just was not able to support. Now, that's why we ended up moving to type MC or metal clad cables, because we wanted to expand the use of this product and overcome some of these issues that were in the standard. So the MC cable first appeared in the mid-1980s. So it's constructed and listed per UL 1569, a much newer performance-based standard, meaning that, for example, let's talk about crush resistance of the armor. So in UL 1569, you can make the product with either an aluminum armor or a galvanized steel armor. Rather than prescribing the thickness of that armor, UL 1569 will specify the amount of crush resistance the product that has to have. It has to be able to withstand a certain force during that testing without damaging the underlying conductors. It's up to the manufacturer to decide or to figure out how thick to make that strip, whether it be made of aluminum or galvanized steel, in order to withstand that testing. So go back to AC cable. The standard on AC was prescriptive, and the steel armor was considered, and I think had to be, actually stronger than the aluminum armor on that product. On this product, on type MC cable, the manufacturers are allowed to use whatever thickness of that material is required to meet the testing results, which means the galvanized steel armored product is not necessarily stronger than the aluminum product. They're both made to the same strength, if you will. Therefore, they can be different thicknesses, and that's what you see is that the galvanized steel thickness is less than the aluminum thickness. Anyways, this is going to offer improved grounding performance when you compare this to type AC. Per NEC 250.122, that I believe we referenced earlier, this is going to give you better performance for, say, 12 gauge and 10 gauge conductors. Why? Because rather than relying on a 16 gauge bond wire in conjunction with the armor, the type MC construction is going to have a full-size equipment grounding conductor underneath the armor, and it's going to be sized per table 250.122. So, for example, as we show in the diagram, 12 gauge phase and neutral conductor will also have a 12 gauge equipment grounding conductor. So just the sizes of these conductors are going to give you this improvement that we show. That means the resistance is going to be less than what you encounter in the AC cable. And if you have less resistance in your grounding path, then you'll have greater grounding performance. You will have less voltage drop over that ground, and you'll have the ability to clear more current. So the permitted constructions of this product, it can go from 18 gauge all the way up to 2000 kc mil. So now we have the ability that we did not have with AC cables to produce this in feeder sizes. It can be made with copper, aluminum, or copper clad aluminum conductors. There's no limit to the number of conductors, unlike with AC cable. Now you can put in oversized, multiple, separate neutrals. You can do your neutral per phase constructions, etc. Again, you're allowed to use the interlocked aluminum or steel metal tape, but again, but as I said earlier, they can be different thicknesses now. And it also allows the corrugated, extruded or seam welded armor, what we call at Southwire our Armor X product. This is going to be the continuously corrugated product that would be utilized for hazardous locations or anytime you need a very, very rugged industrial, maybe even mining cable type of product. So this product can be installed in concealed, exposed locations, in the air handling spaces, the plenum spaces, places of assembly, whereas remember on AC cable, you could not put it into the places of assembly. Dry locations, it can be installed in wet locations if you have that overall PVC jacket. Also, the securing is every 6 feet. On AC, it was every 4.5 feet. So that means your installation cost can be a bit less with this product. So the MC cable cannot be installed as direct burial or in around corrosive materials or embedded in concrete unless it's PVC jacketed. So again, the PVC jacketing over this product allows you to install it in a great many situations. And so this product can be used for branch circuits, feeders. It can be used as service entrance, underground service entrance when it is PVC jacketed. It's direct burial. So very, very flexible product in terms of applications. The PVC jacketing is available in any configuration. As we go through this, you'll see that there are a number of different configurations available for these products. The UL 1569 allows for a lot of variations. So again, these same things that we pointed out earlier. It is sunlight resistant and great for use in the wet or damp locations. In regarding the different types of this product that are available, so we've already talked about PVC jacketed. MCAP we'll be talking about in just a few minutes, the HCF MCAP. But all these different variations on neutrals, multi-circuit, isolated ground, the power control signal version, fire alarm, riser MC, which we'll be talking about towards the end of this presentation, can be made with copper, aluminum conductors. So lots and lots of variation within MC cables. Can get a little confusing at times. So the applications, this is a good low cost or lower cost alternative to pipe and wire installations. It can be used in multifamily residential buildings in addition to your standard commercial, institutional, industrial type of installations. NEC Article 330 addresses type MC cables. And again, this is made per UL 1569, covering metal clad cables. Questions, can it be installed outdoors or underground? Yes, but only if it has the external PVC jacket, or I should say overall PVC jacket on the outside of the product. Can it be embedded in concrete? Yes, it can be, as long as it has that PVC jacket. We do get this question fairly often, believe it or not, where people are wanting to embed the non-jacketed version into concrete. You can't do that. Can it be installed in plenum locations? Yes, as long as the PVC jacket is not on the product. Now, to address this, I've had this question before where somebody wanted to bring in an MC cable from outdoors to indoors and then pass through a plenum space. Can you do that? The answer is yes. You can get the PVC jacketed MC cable, run that in the outdoor portion of the installation. You can also run the PVC jacketed product indoors, except you would not be able to have that outer jacket on within the plenum. So you can remove the outer jacket while it's in the plenum, and that is still an MC cable, and it still has the marking. Now, the PVC jacketed version of the product has marking on the outside of it, but the MC cable also has a tape runs throughout the length of the product, and on that tape you have your marking information as well. So to meet the UL requirements for product marking, you can remove that PVC outer jacket and it will still meet the marking requirements. And so for that particular portion of the installation, the product still continues to meet all of the requirements. So yes, you can take that kind of approach if you need to. Excuse me. Are anti-short bushings required? Well, now on type AC cable, they were required. This is part of the confusion that we run into. On type MC cables, they are not required. No, not required. Now, I believe we still ship the product this way. I know we used to. We would ship the product with the anti-short bushings as part of the packaging. Because there are sometimes there's confusion out in the industry as to whether they need to be used or not, and some people may prefer to use them anyways. So we were including those. I believe we still are. But those anti-short bushings are not required by UL or the NEC when you're dealing with type MC cables. Last one, can the armor be removed and the conductors continued into conduit? This is another one that pops up from time to time where they need a flexible installation and need that flexible armor, but then they're going to take it into, say, PVC pipe. And the answer is yes, you can do that because the conductors underneath the armor are either a type THHN, THWN, are a type XHHW-2 conductor. So those are UL listed and rated products on their own accord. So if you remove the armor, that ceases to be an MC cable, of course, but those conductors are still building wire single conductors that are recognized by the NEC. So yes, you can do that if you need to. Now, the ground path on type MC cable compared to type AC cable, as we mentioned before, since you are able to have the equipment grounding conductor as a conductor underneath the armor, you're not relying on the armor for that grounding, then by sizing it according to the NEC requirements of 250.122, you are going to end up with this better ground path compared to AC. So the ground path for conventional MC, it's a combination of the armor and the grounding conductor only in as much as the NEC requires you to bond that armor. If you look at those sections that are on the bottom of this slide from Article 250 and Article 300, you do have to bond that armor. So yes, it will be grounded. However, you do not count on that as part of your equipment grounding conductor. You are solely counting on the equipment grounding conductor that is included as a single conductor within this construction. Okay. Now that's going to compare to the other products that we'll talk about shortly. Bear with me just a second. Okay, excuse me. So when you're dealing with type MC, yes, you have those larger ground paths, better ground paths than you did on type AC cable. However, the installation of this, it's a mechanical process, and it is subject to some installation variability. So let's say you're going to be splicing together equipment grounding conductors inside of a box, and you end up using wire nuts, or those type of products to splice together equipment grounding conductors. Sometimes it's not immediately obvious that you may have an improper grounding connection. And then you end up with a lot of fill in those boxes. There are NEC requirements, or limitations, I should say, on the amount of fill within the boxes for the conductors. And so if you have to route and splice these equipment grounding conductors within the box, then that is going to impact the reliability of this overall circuit. So that led to the next version in the history of this product, the MCAP cable. MCAP is our Southwire trade name for this product. You may also hear it referred to as an MCI-A. That term is used for the fittings that you use for this product, but I've heard it also used for the product itself, for the cable itself. This product was conceived back about 20 years ago, and the objective was to have an interlocked metal clad cable that could be used in healthcare facilities. Well, I don't have it in the presentation, but for the type AC cable, there is a version of that product that's for healthcare facilities as well. What's unusual about healthcare facilities are a couple of things. The requirement that the armor be an equipment grounding conductor, number one, for certain installations within a healthcare facility. Any of you that are familiar with those, there are multiple areas within a healthcare facility that you have to account for. They're going to require different types of methods. So if you're doing an emergency room versus a waiting room, for example, those are two very different types of installations. You're dealing with different levels of reliability and requirements. So in the healthcare facilities, where you're in patient care areas, there is a requirement to have a redundant equipment grounding conductor, and there's the requirement for the armor to act as the equipment grounding conductor. So therefore, on type MC cables, there is no MC that is a healthcare facility rated product. You have the type AC, which is the old version of the product, and now we have the type MCAP that's available as a healthcare facility version. We'll talk more about that in a few minutes, but that's what really led to this initially. So the cable assembly, it's constructed to allow the armor to serve as the ground path, but you don't have to terminate that ground or bond conductor. So with MC cable, you have the advantage of the larger equipment grounding conductor, but now you have to take that into the device, the panel, whatever, and you have to terminate it. So you have to allow space for it. You have the labor involved. It is another step in the process. Therefore, there's some variability involved with that installation. With this product, you now have a combined ground path of the armor and the uninsulated grounding / bonding conductor. It's a full-size equipment grounding conductor by itself, regardless of the armor, but it is in intimate contact with the armor. So therefore, the armor is counting as the equipment grounding path. So if you look at the construction on the right side of the page, the one on the left, that's a 10 gauge aluminum, 8000 series aluminum bare conductor that's in intimate contact with the armor. The two other conductors, the hot conductor and the neutral, those have a Mylar wrap around those, just like they did on standard MC cable. So there is some separation between those conductors and the armor, but the bare aluminum conductor is in direct contact with the aluminum or steel armor, and therefore that combination is going to serve as your equipment grounding conductor path. So this is going to give you the same level of grounding performance that you had on MC cables, meaning that you have the larger size of bare conductor. It's not just the small 16 gauge drain wire that you had on type AC constructions. So you still, again, you end up with these better grounding paths. But you're reducing the variability of the installation, and you're making it a quicker, easier install. This construction is permitted in sizes 14 through 6. It's again for copper, aluminum, and copper clad. And thanks to UL 1569, we have those same capabilities that we have in product variations that we talked about with MC cable. Now, if you look at the diagram on the right, the one on the far right, you'll notice that the neutral is printed with something. It says armor is equipment grounding path component. This is how you can discern a difference other than looking at the actual grounding conductor, because remember, the grounding conductor is going to be larger than on a type AC cable. But the neutral will have this information printed on it to, again, try to make it even more obvious that you're dealing with an MCAP type of product where your armor is going to count as your equipment grounding path. For the healthcare facility version then, as we discussed earlier in NEC section 517 or article 517, you have a couple of requirements that you have to meet. So that's going to be the separate and redundant grounding paths, and then the fact that the outer metal sheath or the armor has to itself qualify as an equipment grounding conductor or grounding return path. So if you take the existing MCAP construction and you add a green insulated equipment grounding conductor, now you have the HCF version of this product. So this is going to give you kind of the best of both worlds in that it's going to meet the requirements. It's going to not have a conductor limit. You can now do different variations of this product. For example, the MCPCS HCF product is going to give you better ground path performance when you compare it to the AC version of the healthcare facility product. It's going to be easier to install as well. So it's a win-win. This product is UL listed, NEC compliant. So I don't think we need to go any further into that. As I was pointing out earlier, the neutral is marked to make sure that it's you can identify this the version of the cable that you have installed. So our intent here is to increase the grounding reliability, to reduce the variability of the installation, and to give you increased installation productivity. So there's an example showing a box at the bottom where you are dealing with splicing together all of the conductors, and with the equipment grounding conductor in particular, you can end up with a number of those under a twist-on connector like this, or wire nut, if you will. And so you can, especially after you, let's say you twisted it together. I don't know if any of you encountered this before. I have here at home, even, where you twist the conductors together, and then when you're stuffing it into the box, you find out that one of them maybe didn't get twisted very well with the others and comes loose. So this is a real world issue that can occur. So when you are using standard MC cable on the left versus something like MCAP cable on the right, you can see the difference in the box fill, and you've eliminated that green equipment grounding conductor within the box. So this you're relying upon the combination of the armor and the fitting to establish that grounding path to the box. So the fittings that you need for this type of product are MCI rated fittings. Nowadays, most of the common MC fittings that are out there have this MCI -A rating, and they're available from a lot of different people. So they should be readily available out in the field. To install this, this is different from type AC cable. On type AC cable, you folded a 16 gauge bond wire back over the armor, and then you applied the fitting over that. Not on this product. On this product, you snip off the grounding conductor, the bare equipment grounding conductor, at the end of the armor. And now the bonding of that armor is going to occur through the fitting. So cut off the that grounding conductor and then utilize one of these MCAP fittings. They're available in snap-on fittings. So these are fast to where you can push them in, snap them in, and these actually, even though they're quicker and easier to install, they give you actually better grounding reliability. These can carry more ground fault current than your typical ground copper equipment grounding conductor that you utilize. So it can go up to 2 times the amount of current that you can handle on a ground fault situation. So this gives you a fast, reliable way to do the installation. By the way, while we're on this page, I have heard of people treating this like MC cable and taking that bare conductor inside the equipment and then terminating it just like they would have done with the green insulated equipment grounding conductor. Is that okay? Can you do that? Well, yes, you can. That's actually allowable to do that. It's not really what we intended. The intention is for you to do it this way, as we show on the screen. So if you take it in and terminate it, just like you do with MC cable, you're losing the advantage of this type of product in speed and perhaps in grounding reliability as well. Because again, you're having to deal with the installation variation of taking something inside a box and terminating it. So if you look at the inside of the panel with your equipment grounding conductors, they can be terminated on a bar, as we see in the diagram on the left, and on the right, that grounding is occurring from the armor through the fitting to the box. So that eliminates having to run those conductors inside and terminate them. So this is going to simplify your grounding. It's going to simplify the reliability. I mean, it's going to require less time, give you higher reliability because there's less steps involved. This is going to be roughly the same price as conventional MC or AC cable, and there are instructions included when we ship the product on how to do the installation. There should be a tag on it that says that the MCI-A fittings are required when utilizing this product. So the applications, this is going to be a better low-cost alternative compared to standard MC cable when you're doing an armored version of an install versus pipe and wire. It's for the same type of applications. Again, Article 330 and UL 1569 apply, same as before. So frequently asked questions, can the ground conductor be installed in the same manner as AC cable? So let's say the installer treats it like AC cable, and they take the grounding conductor, they fold it back over the armor, and then they apply the fitting over that combination of armor and folded back grounding conductor. Is that acceptable? Probably not. That's not the way the product has been designed and the fittings were probably not designed or tested to be installed in that manner. To properly answer that question, I would recommend that you contact the manufacturer of the fittings and ask them if they tested it and performed their UL testing with that as one of the installation options. I suspect they probably didn't, but you can talk to the manufacturer and find out directly from them. So this has occurred where installers have made the unfortunate mistake of treating this like an AC cable and folding it back over. If the fittings are not listed to be installed that way, then yeah, that's a potential problem. So you want to cut off the grounding conductor flush with the armor and then use MCI-A fittings. You'll be in good shape. Do the fittings have to be MCI-A? Yes, they're specifically designed for this product, and the use of non-MCI-A fittings is not recommended, and I don't think would even be covered, if you will, by UL or any of the manufacturers involved. So, are anti-short bushings required? No, this is going to be similar to MC cables in that these anti-short bushings are not required. Can you install them? Yes, you can. It's optional, but they are not required. The only product that's going to require them is going to be the Type AC cable. Because we have this the flexibility in UL 1569, as we mentioned earlier, we can make a lot of different constructions. For example, we nowadays want to use neutral per phase constructions. And yes, we have those in Type MC products. So you have a dedicated neutral for each hot conductor. And this is going to be available in a number of different types of constructions: the MC, MCAP, the healthcare facility version, jacketed version, etc. Now, the MC PCS, again, this is for power and control our signal. This is, at this point, the primary use that we see for this product is with the 0 to 10 volt dimming on LED lighting circuits. It could be used for any type of control. It could be used, for example, on the blinds, where you have a control circuit, 0 to 10 volt control circuit, to control the opening and closing of blinds on a window. Any type of application like that. This product is listed as a Type MC, so it is compliant with NEC 330. It's also compliant with 725. 725 is the article dealing with Class 2 and Class 3 wiring. This is the lower voltage wiring that are typically going to be used for control and signal. And there are specific requirements in Article 725 regarding the separation of the power conductors or lighting conductors. And then the other circuits, which you have Class 1, Class 2, and Class 3. Class 2 and Class 3 are the ones that we're really concerned about when you're dealing with this type of product. Class 2 products are rated for 150 volts. Class 3 products are rated for 300 volts, whereas the power and lighting conductors that we're dealing with typically on these products are rated 600 volts. So you have different voltage levels. Can you mix those together? Well, no, you can't. So, for example, could you take an MC cable, an ordinary MC cable, or let's say you're using a conduit, you're using a flexible metal conduit, and you're going to pull THHN conductors through that conduit. Can you also pull a Class 2 or Class 3 type cable into that conduit? No. You can't do that because now you're mixing different voltage level products with the same conduit. That's not allowed from, I believe it's in NEC Article 300 that disallows that. It might be 310. So all of the conductors that are going to be inside the conduit are underneath the armor in a construction such as this. they all have to be rated the same voltage. So they all have to be rated 600 volts. So you have that issue, plus you have the issue of the separation requirement in Article 725, dealing with the required separation between the power conductors and then the control signal conductors. This is addressed through the PVC jacket that's installed over the control conductors. So in the MC PCS products, what you have, all of the individual conductors are rated 600 volts. And then the control conductors, which as you can see in the diagram are currently gray and purple. By the way, those colors will be changing in the code and the standards. It would appear at this time that the color combination is going to be changed to pink and purple, because gray could potentially be confused as a neutral in the US. But you have 600 volt rated 16 gauge conductors that are underneath a 30 mil PVC jacket, the light blue jacket in this diagram. And then you have your standard phase conductors from a type MC product or an MCAP type of product, as shown in the middle one. That's the HCF MCAP PCS type product. So we meet the requirements in 725 and 330 by this type of construction. It's available with an overall PVC jacket as well. So for a code compliant installation, you have to meet the requirements as shown on the diagram on the right, separation and the voltage. So this is a code compliant installation in the top graphic, but it's not that efficient. In the bottom one, if you have the conductors just all run together, like I was saying, together, you have a class 2 cable that's installed inside of a conduit along with the power conductors. They may all be rated 600 volts, but they don't have the separation. The MC PCS product is going to give you something that meets everything. It's going to be efficient to run, to install, and it's going to give you the required separation and maintain the voltage level for the control signal cable. Now, sometimes you'll see us refer to that control and signal cable as class 2 or class 3. You have to be careful with that. The voltage rating of the product is not class 2 or class 3. It's actually rated 600 volts. But the application is a class 2 or class 3 application because it is a low voltage application. You're only doing 0 to 10 volts. So you could utilize a class 2 cable for that actual installation application. So it's doing the function of a class 2 or class 3, but it's rated 600 volts. So it's used for LED jacketing. Again, you have that 16 gauge. Those are TFN conductors. And we've already discussed really all of this that's on this particular slide. It's also available in a prefab assembly whip. Other constructions available. I see that I'm running out of time, but I'm almost done. We have the FPLP, the Fire Power Limited Plenum Space conductors. So this is going to be rated 600 volts when used as a type MC. When as a type FPLP, again, you can run it in plenum spaces for fire alarm systems, rated 300 volts and then 105 degrees C dry location. Due to the ability in UL 1569 to go up to 2000 kc mil, that means we can have feeder size MC cables that can be utilized for large structures like high-rise hotels, high-rise buildings, stadiums. So you'll see these large feeder size MC cables installed in a number of these facilities, especially the bottom one that we show in this diagram, Riser MC, which I believe I have on a separate slide. So this is a type MC cable that is compliant with NEC Article 330. This product is really ideal for vertical installations. Why is that? That's because there's a requirement in Article 300 of the NEC that's going to mandate for vertical installations, there's a maximum length that you can install the conductors that are underneath the armor. Okay, there's a maximum length that you can install the conductors without providing some kind of support for them. You don't want to have the conductors falling out of a raceway or out of an MC cable. So you have to do something to support those conductors. And you can do that via a breakout box. You can install chocks to hold the conductors. You can install 90s to relieve the pressure. Multiple ways to handle that. But an even better way to do it is with our Ride MC product. This has a continuous binder jacket underneath the armor that covers the complete the product. This is providing continuous conductor support, and therefore it meets that requirement for the complete length of the run. Therefore, you don't have to do the breakout boxes, you don't have to do the offsets, etc. One last product is just the bare armored ground cable. Sometimes you see this. This is just part of the grounding conductor to the grounding rod type of installation. And so we also provide this as an armored construction as well. I see that I'm at the end of the time. Thank you for joining us today. I appreciate that. And I did finish, at least on time. So again, if you have any questions or comments, we may have a couple of minutes here, but you can reach out to us at cabletechsupport@southwire.com with any questions about today's presentation or any type of application support you may need with our products. Now, Beth can probably address this better than I, but at least for me, I'll be taking a bit of a break from these presentations for the month of October, but I believe that we'll be back in November with more of these. But Beth, back to you, and you can discuss that.
Beth has jumped off early because she has another commitment. So I wanted to thank everybody for joining us today. We welcome your feedback or suggested topics for the month of November and December. I have shared my email in the chat box, yushin.hallwig@southwire.com. So please feel free to share your suggested topics, either it's product related or field installation support. Thank you so much for joining us today, and we look forward to seeing you guys again in November and December.
Yes, thanks for attending today. So goodbye.